Hello everybody. So now we are going to discuss the second option, or the second way of doing the solution of the cases like this, where we have degrees of freedom of the process 0 and we don't have any unit that has 0 degrees of freedom. So the second option is to do what we can call a tiering strategy. The tiering strategy, as its name kind of tells what it means. So tiering means that you cut something into two pieces, and this is what we do. So we now know that we have some components in stream 2, we don't know their flow rates, and there are some components in stream 3, we don't know their flow rates, and the same for 4 and 5. But I know that the degrees of freedom of the mixer is 4. So it means that if I have 4 extra information, I can solve the mixer, and if I solve the mixer, I will calculate stream 2. This will give 4 information to the reactor, which will solve the reactor because it has 4 degrees of freedom, which will give 4 information to the separator, which will have 0 degrees of freedom. It will have already 0 if I know stream 4. So the tiering strategy is a strategy that depends on trial and error, meaning that you will assume something and then you will recalculate it. So what we do is we cut one stream in this loop, which would be stream number 4, for example, and I will have 2 values for the components in stream 4. Of course, this is for the solution. This is what we do for the solution. So we will have values that I will assume some values for the components in stream 4, and I know these values are 99.9% are not right values, because you will not assume the correct values because it's assumption. So unless you are super lucky to assume the answer from the first time. So we can assume these values, and then we do the calculations. This is an assumption. It's not an assumption to get the final answer. This is an assumption to start the calculations. Okay, this is not the assumption like assuming a basis. This is not a basis. This is an assumption of the solution. Okay, so I assume the solution, and then I will solve the mixer, calculate stream 2, solve the reactor, calculate stream 3, and recalculate stream 4 one more time. Okay, so this is what I do. I assume something and then I go with the calculations until I calculate it one more time. And now I have one of 2 options. The first option, which is that the assumption that I made was correct. And if the assumption is correct, then the calculated value of stream 4 is going to be equal to the assumed value because it's correct. But this is very unlikely to happen. So what will happen is that this number would be different from the assumed, or the numbers that I calculate would be different from the numbers that I assumed. So what I would do is I told you in the beginning, this is a trial and error. So I try, and then this try is not correct. So I'll use these numbers to be the assumption for the next step. So I will redo the process again, and I will calculate the stream number 2 based on the new values of stream 4. And then solve the reactor, then calculate stream 3, recalculate stream 4. I will compare these two. For the solution to be right, the value of the assumed and the calculated numbers should be very close. It's not very probable that they would be exactly the same. There will be some error, but they will be very close. And we will keep doing this, going through the loop again and again and again until the solution converges. Converges mean that the assumed and the calculated values have a very small difference, and this difference will be less than what we can call the tolerance. The tolerance is how much error is acceptable. So let's say I assume that I would be happy with difference of 0.01. So if the difference between these two numbers is 0.01, so خلاص, I can consider this as a solution. So this is simply what we are going to do. We are going to have two values for stream 4. Of course, you can assume any one of the values in the whole process. You can assume stream 5. You can assume stream 3, 2, 4, whatever. I'll do this for stream 4, but you are totally free to assume any of these numbers that you have. Okay. And based on the iterations, you can do 2, 3, 4, 5, 10, 100, as many iterations as needed until the solution converges. That the difference gets smaller and smaller and smaller until we reach the final answer, or the correct answer. To do this, we have to do the balance calculations or the balance equations for each one or use the balance equations for each one of them separately. It's not going to be like the previous case. In the previous case, we will do or put all the equations together. Here we will solve unit by unit, and this is what I mentioned in the 2 videos ago, that this is called the sequential method. Sequential, that are going in sequence. So we can, of course, the calculations are going to be kind of tricky to do manually. However, you can have a good guess for the initial assumptions, which will make the conversion easier. And this is something that depends on your understanding of the problem. This strategy has the advantage of showing you all the compositions and flow rates of all the streams in the same time, so you can see the numbers directly while you are doing the calculations. So this is the idea. I hope the idea is clear. You just tear the stream, break it into 2 parts, you assume one of them, and you recalculate it, and you keep the calculations until the 2 numbers are very, very, very close. So this is one method that is very useful, and it doesn't have the restriction of the linear equations, like in the case of solving the equations simultaneously that we did last time. So it doesn't require that much computational power or the time that you would put to list all the equations in the form of matrix. However, the solution or getting the solution depends on some things. It depends on the initial guess that you put here. The initial guess, as it's close to the final answer, it's better because it makes the conversions easier. And the second, that you have a tool that will enable you to do the iterations, that will do the iterations automatically. So this is what we are going to see next time, inshallah. I am going to do the exact same do this solution using Microsoft Excel as well. There is a tool in Microsoft Excel that's a very, very, very powerful tool that we can use to do iterative solution like what we are mentioning here. So I'll keep this for next video, and I'll see you then, inshallah. Goodbye.